Okay. First one, the probability of rolling a number greater than 1 on a standard die. So how many numbers are greater than 1 on that die? 5 of them, thank you. So 5 numbers are greater than 1 out of how many altogether? Is he right? Is it 5 out of 6? Yes. Okay, good. All right. Next one, the probability of rolling an even number and then an odd number. So this one, we have 2 probabilities we're going to multiply together. What's the probability of rolling an even number? All right, so Eamon gets 3 out of 6. Raise your hand if you also have 3 out of 6. A few of you do. Good. Did anybody want to make it 1/2 before they started working with it? A couple of you did that. So they're both fine. You can simplify at the beginning or the end, and you're going to get the same answer. I'm going to do it the way that Eamon suggested, and we'll just simplify at the end. So he said 3 out of 6 for even. And Lonnie, how about odd? What's the probability of rolling an odd? Also 3 out of 6. Good. So remember to multiply fractions. You multiply numerators and you multiply denominators. And so I get 9 out of 36. And some of you are really good at simplifying that fraction in your head, but if you're not, I want to remind you we have Desmos. So if you haven't simplified that fraction yet, please open Desmos either on a computer or a phone. Desmos is going to work much better than any other calculator right now. It's so easy. All right, so in Desmos, you're going to do 9 divided by 36. And if you're watching the video, it's a little bit off the screen over here, but on the left, there is a little fraction that I'm going to press, and it simplifies it to 1/4. So we get 1/4. Now, if I wanted the decimal, I would turn off the fraction and I would put 0.25. And actually, the decimal might help me in placing my answer on that number line, so I'm going to write them both down. So I'm going to put 1/4 or 0.25. Morning. All right, next one. Actually, you know what? I'm going to do that 5/6 as well, and put that up there as a decimal. And that way, we will have decimals to compare. I'm going to use 2 decimal places for each one. So 5/6 will round to 0.83. Okay, the probability of choosing a red card from a standard deck of cards. So some of you knew right away that half the cards were red. Some of you wanted to think it through. So there's 13 red diamonds, 13 red hearts. So either way you did it, you would end up with the same answer. If you counted up all the red cards and you got 26 red cards because of 13 red diamonds and 13 red hearts, divided by 52, that would simplify to the same answer that you would get if you just realized that half the cards are red, which is 1/2 or 0.5. And if I want 2 decimal places, I can just make it 0.50. Okay, take it. Okay. A drawer holds 4 blue socks and 1 red sock. You choose 2 socks randomly without replacement. What is the probability that they're both blue? Can anybody explain what it means when I say without replacement? Raise your hand if you think you could explain that to us. Okay. It means that I take the sock out and it stays out. I'm going to put that sock on my foot and I don't have 5 socks in the drawer anymore. I have how many? I took 1 out, right? I've got 4 left. All right, so first time, 4 blue socks, 1 red. Kelly, what's the odds that I get blue the first time? 4 to 5, very good. 4 blue out of 5 altogether. Now, in this scenario, I got that blue sock the first time, so now I have fewer socks altogether and I have fewer blue socks. Kelly, what's the probability of getting a blue sock on the second time? 3 out of 4. Because once I take a blue sock out, I only have 3 left out of 4 altogether. I'm going to pause there for a second because I want to see what questions you have before we multiply. So remember, we're going to multiply numerators and denominators. Some people who are really good at simplifying might see that you can actually just cancel out a 4 on top and a 4 on bottom, and that will simplify your life a lot. But if you don't like that, just multiply. 4 times 3 is 12. 5 times 4 is 20. You can simplify in your head, or you can simplify on Desmos. All right, so I've got 12 over 20. To the left of my fraction, there's a little fraction. I click on that one, it gives me 3/5. I can leave it as 3/5, or the decimal 0.6. .6, and so that I can compare it to the others, I'm going to put 2 decimal places. That will help me compare it. All right, so now we want to put all of our answers on the scale, and some of you guys put A, B, C, D, and that's fine if that's how you ended up doing it, but if you haven't done this yet, I would suggest that you just put the numbers on there. That will make more sense to you later. If something is impossible, what's the probability it's going to happen? 0, good. So right here, this would be a 0 probability. Equally likely, what's the probability? 50%, good. 50% as a decimal would be 0.50. And if something is certain to happen, what's the probability it's going to happen? 100%. And 100% as a decimal is 1.00. So now, take your answers, 0.83, 0.25, 0.50, and 0.60, and just place them on your number line. All right, did anybody put a number right here on the unlikely? Yeah. Which one did you put there? 0.25, very good. It'd be halfway between 0 and 0.5. So it's unlikely I'll roll an even then an odd, but it's not impossible. Oops, I don't know what I was writing there. 0.25, which is the B. Okay. Did anybody put a number right here? Emerald, did anybody else put one there? A little bit after the likely? You, Lisa, did you put one here? Which one? D? The 0.6? So I do like that the 0.6 is going to be likely. It's going to be on this side here. I would put the 0.6 just a little bit lower, but I definitely agree that it's going to be on that side. Yeah, over here we could put the 0.83. Very good. So let's put both of those. Okay, so for this one we said 0.83, which was answer A. And then over here, 0.60, which was answer D. So I think we still have answer C to put. Oh, it was already on there, right? So the 50% is already right here in the middle. So I'll just put that right there, answer C. All right, anybody have a question on that? All right, so here we're using information from the class. So what number is going to go here in the middle of my Venn diagram based on what we collected? 7. Yeah, good. 7 people liked both board games and card games. Okay, how many are going to go over here? It is. It's 0, because 0 people like just board games. And how about just card games? 3. All right, and then we also have 3 for neither. Where should I put them? Yeah, outside the circles. Good. So these people here, they liked neither board games nor card games. They go here. All right, so if you have not yet filled in your Venn diagram, please do that. Remember that these notes are notes you can use on your check-in today. All right, so 1, 2, and 3, we talked about problems like this last time. And then 4 and 5, these are new ones. All right, probability that a student likes board games. Now it's not 0 because we see that there are some students that like board games. How many like board games? Yeah, it's 7. So remember, for board games, we're actually looking at this whole circle. So the probability that a student likes board games is going to be 7 out of how many students are there? Yeah, 13 altogether. 10, 13. And I'm going to write the words because I want to know what it is I answered. Probability a student likes board games. Okay. Does anybody remember what the U means? It literally means union, like united together, but it means the word or. So it means the probability that they like board games or card games or both. And you can see the word or here. So probability a student likes, I'm going to abbreviate B or C or both. All right, so take a minute and see if you can find that probability. And what did you get? 10/13. Did anyone else get 10/13? Okay, good. Because I'm looking at all of the numbers in the circles, and they add up to 10 out of 13 students altogether. All right. This third one is the word and. When you see that symbol, it means and. So the probability the student likes, and it has to be both. Both B and C. Okay. Stephanie, did you get that one? Okay. You guys take a minute and see if you can find out the probability a student likes both B and C. Let's see. So were you looking at the left 3 or the right 3? What's that? Oh, so B, actually, if you look carefully at B, it has 0 and it has 7, right?
10.
All right, and so we have 10 people that like B or C, right? But for this one, when it's both, you're looking at just the overlap. So what do you guys think? What number's in the overlap between the two circles?
7.
Anybody want to agree with 7? Yeah.
Yeah.
All right. So I appreciate you guys really invested in that one. And yes, it is 7 out of 13 students altogether, because they have to like them both. And so they have to be in both the B circle and the C circle, the overlap. So I want you to notice that problems 1, 2, and 3, they all have the same denominator. The denominator is the 13 students in the class. Always 13. However, we're going to do a different kind of problem. They're called conditional probabilities. And whenever you have a conditional probability, the denominator will change. It will not be the whole group, 13. You can tell it's a conditional probability if you see this line, because the line like this, it means given. It means the word given. So when I see the probability of B given C, that means the probability a student likes board games given that they like card games. It means I already know they like card games. So if I already know they like card games, I'm not considering these people. I'm only considering the people who like card games, which is how many people? Altogether. How many are left that I did not cover up? You see the 7 and the 3, right? So that makes 10. So since I know that they like card games, 10, that's going to be something over 10. Okay, now out of those 10, remember I'm not thinking about anything else. Out of those 10, how many of those 10 like board games?
7.
What do you guys think? Is he right? Can you guys see that that 7 is inside the board game circle? All right, so out of the 10, 7 like board games. The given problems are a little bit tricky, but I think once you guys get to do one on your own in the next problem, it'll get a little better. All right, this is backwards. Probability a student likes card games given that they like board games. So this time, given that they like board games, I'm only considering the people who like board games, which is how many?
7.
Yeah, I'm only looking at these 7 here. So that means it's going to be out of 7. Okay. Out of the 7 students who like board games, how many of them also like card games?
10.
So it can't be any more than the denominator.
Oh, 7.
Right. So look at how I'm covering it up. Out of the 7 who like board games, 7 of them also like card games, which might seem like a strange fraction, but if you think back to it, everybody who liked board games also liked card games, right? Nobody liked just board games. So 7 out of 7, which is 1, which is certain. If I already know that you like board games and you're in this class, then I also know that you like card games. Okay, I know that those are a little bit tricky, but I want to give you some time to practice with a partner. If you're sitting next to somebody, they are your partner, and if you're not, I will assign you a partner. All right, so let's go over. I'm going to start by filling in the Venn diagram like you guys did. So we have 8 that like just tacos, and 7 that like just ramen, and 5 that like both, and 3 that liked neither, which was 23 people altogether. It says it right here. All right, the probability a student likes tacos, please make sure you remember to add both of these together, and that gives you 13 out of everybody, 23. This one was an or, and remember for the or you also include both. So tacos or ramen or both. So altogether you should have had 20 out of 23 altogether. And then this one is an and it has to be both. When it's and, it has to be both. So you look at these two circles, and this number 5 is the students that like both out of 23. All right, so all of these have a denominator of 23. Who has a question on that part? Okay, when you see that line, remember it means the word given. And in these problems, your denominator will not be the whole group. So given that they like ramen, I looked at the ramen circle and I saw that there were 12, and that told me my denominator is 12. So of those 12 students who like ramen, how many of them like tacos? What did you guys find? How many like tacos in that group circle? 5, right. Only these 5 also liked tacos. So the probability a student likes tacos, given that they like ramen, is 5 over 12. The next one, probability a student likes ramen, given that they like tacos, you look at the taco circle, and this one was 13. So that's your denominator. In the taco circle, how many of them also liked ramen? Still 5. Very good. Okay. Now stop recording and take questions.